This is page 1. This is page 2. This is page 3. This is page 4. This is page 5. This is page 6. This is page 7, and it is a blank sheet of paper. This is page 8. This is page 9. This is page 10. This is page 11. This is our lesson that we call from whole numbers 1 to fractions 1 over 1. Whole numbers tell us how many things we have to talk about. For example, we have 1 DVD with this package. We should have 11 sheets of paper. The sun is about 92 million miles away from us. There are 24 hours in one day. So whole numbers look like that, and it tells us how many things we have to talk about. The first thing we notice about a fraction is that we have one number written over another number separated by a line. The way you read it is from the top down. from the top down, we have 1. This says divided by 1. So the line is a mathematical symbol that says divided by. The top number, so we'll know what these two numbers actually do for us. The top number is going to tell us how many pieces of something we have. It's just like a whole number. It tells us how many that we're talking about. In this case, something has been cut up into pieces, and so the top number is going to tell us how many pieces of something we have that's been cut up into different pieces. This bottom number is what tells us how many equal pieces something has been divided into. And I'd like to say that again. The bottom number will be telling us how many equal pieces something has been divided into. This sheet of paper is still all in one piece. We haven't cut it up into pieces. So it's only been divided into one piece, and we have one piece of paper. I'd like to get you to take that page 1, that one sheet of paper right there, and let's tear it in half. You go first. Or we can say we're going to tear it in 2. I'm going to try it right now and see how it works. That's my 2 pieces right there. How did yours turn out? There are 3 ways that we can say what we have right now. I could say, if I take these 2 pieces of paper and take one piece in one hand and one in the other hand, I can say I have one piece of paper in one hand and one piece of paper in the other hand. Or I could say I have a fraction of a sheet of paper in one hand and I have a fraction of the sheet of paper in the other hand. Or I could say I have 1/2 in one hand and the other half in the other hand, even though my halves aren't exactly equal in size, like a real half should be. Now what I'd like for you to do is to just place those pieces aside for a while, and let's look at page 2. Page 2 says that 1 equals 1/1. As you can see, this page is still in one piece. We can also say that we have one piece of paper that has been divided into one piece. If you have a sheet of paper that is still in one whole piece, then it's the same thing as saying that we have one sheet of paper. That's why 1 equals 1/1, and 1 divided by 1 equals 1. So again, we have one piece of paper that has been divided into one equal piece. Next, let's look at page 3. It's like page 2. It's still in one piece. So I wrote 1 equals 1/1 again. If we hold page 2 and page 3 together, like I have here on the stand, we have 2 sheets of paper. So I wrote the fact that 1 plus 1 equals 2. That's whole numbers. One sheet of paper here on page 3 and this one sheet of paper, page 2, 1 plus 1 equals 2 sheets of paper. Since both sheets are still in one piece, I could write it like this. This page is the same thing as one piece of paper that's still in one piece, plus I have page 2, one page 2, which is still only been divided into one piece, which means it's not been divided up into anything at all except one piece. So 1/1 plus 1/1 equals 2 over 1. Or one sheet of paper that's still in one piece plus another sheet of paper that's still in one piece equals 2 sheets of paper. Both of them are still in one piece. So if you do the math operation, 2 divided by 1 equals 2. Or you could say 1 will go into 2, reading it from the bottom up. 1 will go into 2 times. You know, I have 2 1/2 written down here at the bottom. Even though my sheets of paper aren't exactly halves, if I took this piece of paper here, which I called a half before, and added it to these 2 whole sheets of paper, I would have almost 2 1/2 sheets of paper here. Let's look at page 4. If I counted to 4, I could write it like this: 1, 2, 3, 4, and I could keep going. The dots mean that I'm keeping on going. 3 plus 4 equals 7. We're working with whole numbers here. But I can also count to 4 expressing it like fractions. I could say 1 over 1, 2 over 1, 3 over 1, 4 over 1. Of course, 1 over 1 equals 1, 2 over 1 equals 2, 3 over 1 equals 3, 4 over 1 equals 4. Now, let's place these pieces aside for a minute and take a look at page 5. Page 5 has 1/2, then I have a line drawn down through here, and then 1/2. What I'd like for you to do is to cut along this line right here and make 2 exact equal halves if you can, and then there'll be 2 equal pieces like that. Now we do have 1/2 of a sheet of paper here and 1/2 of a sheet here. These are cut exactly in half. Where we tore them earlier, we got 2 halves, but they weren't equal halves. And halves really have to be equal in size. We're going to do the same thing with page 6. We have 1/3 a line, 1/3 a line, and 1/3. And then if you'll cut along those lines, you should get 3 equal pieces of paper. All 3 pieces should be just about the same size exactly. Next we have page 7, which is a blank sheet of paper. The reason I included the blank sheet of paper is because I want to show you why fractions, they start becoming a little bit of a pain for people, because sometimes we have to do things called finding the least common denominator and just all kinds of things that we have to do to fractions. And one of the reasons we have to do things like that and find the least common denominator in things is because if I told you that I wanted you to add 1/3 of a sheet of paper, and I can get one of my 1/3 sheets out for this, and let me find my piece of paper that I cut in half here for us. If I decided to line all this up, and I have one piece of paper, let me get the rest of these out of the way for you. Let's start that part again. I have one sheet of paper there for you to go by. Let's just say that I had 1/2 of a sheet of paper and I wanted to add 1/3 to that half. What fraction of the whole sheet of paper here have I just now covered up by adding 1/2 and 1/3? It's hard to say sometimes. As a matter of fact, it would be hard for me to guess. But we could take a guess and say, well, I've got most of it covered, but I need to know exactly what fraction of the entire sheet of paper that I have covered right now. So we're going to figure that out. Before we do figure it out, let's take a look at page 8. This says 1/6, 1/6, or 1/6. So I have page 8 marked off into 6 equal pieces. You don't need to cut these up. I'd like for you to just leave that as it is. Now we have a whole sheet of paper. I just simply have it marked off in 6 equal pieces, but I haven't cut it up or anything like that, so it still looks like page 7. But this is page 8, so I've got these marks on it. Let me show you what happens when we add 1/2 and 1/3 like we were going to do before. You see, if we just add 1/2 and 1/3, we're not able to get an expression that we need to make it sound like a fraction of the whole sheet of paper. So this is where finding the least common denominator comes in good. Anytime you see something like 1/2 and 1/3, you can multiply these two bottom numbers together and multiply the two top numbers. 1 times 1 equals 1. I'll show you this again in a minute. 2 times 3 equals 6, and so 1/6. 1/6 means that we could express the fraction 1/2 in sixths by saying, well, 1/2 would be 3/6. 1/3 is 2/6, and I'll show you that again in a minute, just a little bit more on the next pages. But if you can see our whole sheet of paper, I've got it marked off in 6. See how 1/2 the sheet of paper is going to cover 3 of those sixths? Then it looks like that 1/3 of the sheet of paper covers 2 of the sixths, and then we have 1/6 left over. So we've covered a bunch of the sixths. Let's see how many we did cover. 1, 2, 3, 4, 5. So that must mean that 1/2 plus 1/3 is 5/6. On page 9, 10, and 11, I'm going to show you how we write fractions and add them and things that we have to do. Remember, we had our 2 equal halves before when we cut that piece of paper into 2 equal halves. And we also had the sheet of paper that may not exactly be equal halves, but if we add those 2 halves together, it'll be the same result. We should end up with our whole sheet of paper. We might try that. 1/2 plus 1/2 equals 2 halves. See, we have something here. We got a piece of something that has been cut up into 2 pieces. Well, we have the other piece of the same thing that has been cut into 2 pieces, and they're 2 equal pieces because that says it is. It's the same number. That means they're equal in size. So if we take that one piece, add it to the other piece, we have 2 pieces, or 2 halves, and mathematically you say 2 divided by 2 equals 1, and you figure it by saying 2 will go into 2 one time. If we have one of our thirds, we had one sheet of paper we divided into 3 equal pieces, or in thirds. One of those thirds plus another one of those thirds equals 2 thirds. Well, if we had to get the other piece, 2 thirds plus the other piece, which is the other third, would equal 3 thirds. We would have all 3 pieces. All of them are the same size. It's something that's been cut up into 3 equal pieces, just like we did. Well, 3 divided by 3 equals 1. Remember our sixth, our littlest pieces. 1/6 plus 1/6 equals 2/6. Well, this fraction here will reduce. That's what we call doing that. We're going to try to make these numbers smaller if we can. It's easier to work with if we have smaller numbers. So we can actually divide both of these numbers by the same thing. We can divide them by 1. 2 divided by 1 would be 2. 6 divided by 1 would be 6. So we would end up with the same number. And if we divide the top number and the bottom number by the same thing, which we're allowed to do, one of the rules of math, if you divide the top number by something, and if you can divide the bottom number by the same number, that's allowed, and that will give you a reduced fraction. Well, we can divide both of these numbers by 2, because 2 will go into both numbers. 2 will go into 2 one time. 2 will go into 6 3 times. So, 2 of those pieces of paper that are marked off in 6, those 2 sections, is the same thing as 1/3. And if you remember, when we put our 1/3 piece over that sheet of paper we had drawn into 6, it covered 2 of those 6. So that's why 2/6 equals 1/3. 3/6 equals 1/2. If you have 3 pieces of something that has been cut up into 6 pieces, then you have half the number of pieces of the whole thing, because 3 is 1/2 of 6. So we can also say, well, we're going to try to divide both these numbers by the same number if we can, to see if we can get a smaller number. Can we divide these numbers by 2? 3 divided by 2 would not give us a whole number. 6 divided by 2 gives us a 3, but 3 divided by 2, that rules that out. Let's go on and see what happens if we divide both of these numbers by 3. Well, 3 divided by 3, we can do that and get 1. 6 divided by 3 is going to give us 2. And if we had all 6 of those pieces, which we didn't cut the paper up into 6 pieces, we left them all there. So we had 6 pieces out of something that had been marked off into 6 equal pieces. We just didn't cut it up into 6 equal pieces, but we had it marked off. And that's why when we had all 6 pieces, 6 divided by 6 equals 1. Or 6 pieces of paper divided by a sheet of paper that's been marked off in 6 equal pieces equals 1 sheet of paper. Let's take a look at page 10. I have something that might lead us into a type of math that we call algebra later on. Remember me trying to add that 1/2 a piece of paper and that 1/3 of a piece of paper, and I didn't have the other sheet that was marked off in 6. I just held it up to the whole sheet of paper, which I believe was page 7, which was just a blank sheet of paper. When I held those up, I really couldn't tell how much of the paper I had covered. I couldn't express it as a fraction that made sense. So in other words, you can't say 1/2 plus 1/3 and get an answer that really makes sense. We have to use other numbers to express our answer in. So what we're going to do is we're going to find the least common denominator. The easiest way to do this and to find a common denominator is you can always take these 2 bottom numbers and multiply them together. 2 times 3 is 6. 2 times 3 is 6. So you could fill these 2 numbers in. And then what we will do is that we have to figure out by looking, I'm going to show you page 11 here in a second, so get it ready, but let me read these things to you first. This says 1/2 plus 1/3 equals x. X is the answer we're looking for. It's going to be a number. And that in algebra, that's what you do, is you'll use a letter as the number that you're trying to look for. Well, we must know that it equals something. Here's what it does do. We know that 1/2 from doing our little exercise earlier was 3 of the 6 that we covered, and 1/3 covered 2 of those 6 on the sheet of paper we had marked off. So 3 of those, 3/6 plus 2/6 equals 5/6. So x in this problem here is going to be the number 5/6. I'm going to show you with page 11 how we get that now. We want to know how many sixths that 1/2 was equal to. Remember, we had to convert this into sixths and this into sixths. To do that, we say 1 divided by 2 equals what number divided by 6? The way you figure that out is to what we call cross multiply then divide. We multiply 1 times 6 and you'll get 6. 6 divided by 2 is 3, so your answer 3 is there. And it looks like this: 1 times 6 divided by this 2 equals 3. If we're trying to convert the 1/3 fraction into sixths, and we had to do that right here, we had to find out how many sixths or some kind of common denominator. We did get the least common denominator in this case. So, how many sixths does 1/3 equal to? 1/3 equals how many sixths? You cross multiply again. 1 times 6 divided by 3 equals 2. And so just to recap that again, 1/2 plus 1/3 equals something. That's what we were trying to figure out a while ago when we put the pieces together. To find a least common denominator or a common denominator, in this case we did get the least common denominator. 3/6 plus 2 to the 6 equals 5/6.